then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Greetings, math people. Today we're going to investigate a pretty interesting mathematical question. And the question is, does 0.9 repeating equal 1? So the 0.999 and the 9 just keep repeating indefinitely. Does that number equal 1? Now, some of you may think logically that 0.9 repeating couldn't possibly equal 1. That would be your logical conclusion. And that would be quite obvious to you. Unfortunately, every mathematical fact isn't the obvious choice. So we're going to investigate and see if 0.9 repeating actually is equal to 1. In fact, we seek to prove that 0.9 repeating is equal to 1. And we'll first look at it from a pretty logical standpoint. We're going to look at fractions that have a denominator of 9. For instance, 1 over 9 is 0.1 repeating. 2 over 9 is 0.2 repeating. 3 over 9 is 0.3 repeating. And 0.4 over 9 is 0.4 repeating, etc., so forth and so on. So whenever you have a fraction and your denominator is 9 and your numerator is less than 9, and dare I say less than or equal to 9, the decimal representation of that fraction is your numerator repeating. So then logically, if my numerator is 9 over 9, that should equal 0.9 repeating. And also we understand that 9 over 9 is 1. And so that should prove that 9 over 9, or 0.9 repeating, is equal to 1. So that's more of a logical argument. It's not really a technical mathematical proof. So I want to look at a couple of more scenarios to try to bring this point all the way home, that yes, indeed, 0.9 repeating is equal to 1. Let me define a variable. And let me say x equals 0.9 repeating. So x equals 0.9 on off to infinity. So if x is 0.9 repeating, that means that 10x is 9.9 repeating. That should be fairly obvious. You multiply a decimal by 10, you just move the decimal once to the right. So if x is 0.9 repeating, 10x would be 9.9 repeating. Now let's see what happens if we take the difference of these two, meaning 10x minus x. Again, 10x is 9.9 repeating and x is 0.9 repeating. So when we subtract those two, we're left with 9. And 10x minus x is 9x. And again, their difference is 9. So 9x equals 9, which means that x equals 1. But what do we define x as in the beginning of the problem? 0.9 repeating. So once again, we see that 0.9 repeating is equal to 1. Now, if you're still a skeptic and still don't believe that 0.9 repeating is equal to 1, I have one last argument to convince you. Now, this is more of a mathematical technical argument, but it is a moving argument nonetheless. Let's say I represent 0.9 repeating as a sum of infinite terms. In fact, we call this an infinite series. And the terms I'm going to add are going to be 9 over 10, which is 0.9, plus 9 over 100, which is 0.09, plus 9 over 1,000, which is 0.009, and then plus 9 over 10,000, to 9 over 100,000, etc., all the way on, going all the way down to infinity. This type of series is called a geometric series. So this type of series is called a geometric series. And when we have a geometric series, there's a couple of things that are important that I like to point out. One is the first term of the series, which in this case is 9 over 10. So we call that first term A1. So the first term in the series is 9 over 10. Another interesting thing, so just to give you some perspective on what makes a series a geometric series. So a geometric series is a series where I'm multiplying each term by some constant number to get the next term. So if you look at all these numbers as I go from 9 over 10 to 9 over 100 to 9 over 1,000 to 9 over 10,000 and so on, you can see I'm multiplying each term by 1 over 10 to get to the next term. So 9 over 10 times 1 over 10 is 9 over 100. 9 over 100 times 1 over 10 is 9 over 1,000, etc. This number that we multiply each term by, we call that term R for the rate. So in this case, R equals 1 over 10. And when you have an infinite series, if the absolute value of R is less than 1, we say that series converges, which means we can add up all of the terms and get a finite number. So as I take 9 over 10 plus 9 over 100 plus 9 over 1,000, etc., going all the way to infinity, I can figure out what that sum is. In fact, we have a very good formula for finding the sum of an infinite geometric series. And the formula is the sum equals A1 over 1 minus R. Now again, in this problem, A1 is 9 over 10 and R is 1 over 10. So our sum is 9 over 10 over 1 minus 1 over 10. Well, what's 1 minus 1 over 10? 1 minus 1 over 10 is 9 over 10. So our sum is 9 over 10 divided by 9 over 10, which of course is 1. So our sum, if I add all these terms up, they're going to equal 1. And again, what did all these terms equal from the beginning? 0.9 plus 0.09 plus 0.009, it equals 0.9 repeating. So our last argument to demonstrate that 0.9 repeating is equal to 1. If you don't agree with this, I would like to see your rebuttal. I'll wait.
Specialize in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.